Okay, here's the rundown for what we did for section 13.7, day 2. Today's Tuesday. The first thing we talked about was the difference between the multiplication principle, the permutations, and combinations. So multiplication principle, meaning the total number of ways to complete a task. Permutations is where the order is super important, and we have a formula that we can use right down here. And then combinations, where the order is not important, and we have a formula that we can use right down there. And it's all new to us before. So the hardest part with these problems, we took a look at some word problems. The hardest part was figuring out what type of a question this is, what type of a question it's asking us here. So number 2, the International Airlines Transportation Association assigns a 3-letter code to represent airline locations. As an example, SFO represents San Francisco. So how many 3-letter codes are possible? Well, for our first choice, our first task is to pick any one of the 26 letters of the alphabet. Our second task is to pick, again, 26 letters of the alphabet. And then our third task is to again pick 26 letters of the alphabet. And the multiplication principle says that we multiply these together to get a grand total of 17,576. So this is a multiplication problem. Multiplication principle problem. Part B says, what if the letters are not to be repeated, right? Well, okay, I can choose any one of the 26 letters for the first task, but the second task, I can't choose the letter I chose before because I can't repeat it, so that gives me 25, and then so on to 24, for a grand total of 15,600. So you can see I lose quite a bit of total airport terminals codes if I am not allowed to repeat. Here's number 3, the CD problem that we took a look at. If 5 CDs are on the floor, how many different ways can you pick up 3 of them and arrange them on the shelf? Okay, so if I pick up first CD, third CD, and the fourth CD, and I put them on the shelf in the order of 1, 3, 4, I could also put them in order of 1, 4, 3. So those are different. So because they're different, this is a permutation problem. And we use the permutation formula that says from 5 things, we want to permute 3 of them, so we have a grand total of 60 ways. Okay, the fourth thing that we did was the CD problem again, but it was a little bit different. If 5 CDs are on the floor, how many different ways can you choose 3 of them to listen on a road trip? So you're running out the door, you just want to grab any 3 of them. This is a combination problem because we don't care what order we listen to them in on the road trip. We just want to have them with us. So of the 5 CDs on the floor, which ones can I grab and take? That's a combination problem. So I use 5, choose 3, and I get a grand total of 10 if I did that correctly. So please double check me and make sure that's right. Okay, number 5, probably the most fun problem of the day, and probably the most difficult, the repeated letters problem. How many ways can we arrange the letters of the word Google? All right, so you'll notice, right, I wrote the word Google down. I'm going to go G-O-O-G-L-E. Then I'm going to rearrange some of the letters. Here we go again, G-O-O-G-L-E. And the problem is you cannot tell the difference, right? So what this question is really asking us is how many distinguishable permutations of the word Google are there? So that meaning we can distinguish one from the other. See, these are indistinguishable. So here's how we broke it down. I'll run this through you with you here. So task number 1 is choosing the position of the G's. Task number 2 would be choosing the position of the O's. Task number 3, choosing the position of the L's. And task number 4, choosing the position of the E's. Before we did that, over on the left-hand side, we wrote down all the total letters. We had 6 total letters for G, O, O, G, L, and E. 2 G's, 2 O's, 1 L, and 1 E. So we were working with that, okay? So, okay, and now that we have our tasks associated, we say, how many ways can we choose the position of the G's? Excuse me. Well, since there are 6 slots to choose from, and I have 2 G's, I have 6 choose to. Task number 2, the position of the O's. Well, since I've already taken up 2 positions, I only have 4 left, and there are 2 O's, so that's 4 choose 2. Next, I've taken up 4 of the slots. I only have 2 slots left, and there's only 1 L, and finally, 1 slot for 1 E. So these are my tasks that I have to do. And the multiplication principle says that we need to multiply these all together. So I did that here. I have 6 choose 2 times 4 choose 2 times 2 choose 1 times 1 choose 1. And when we write out all of the algebra down below in the formulas, we notice that this cool pattern of canceling happens to be going on here. The 2 cancels the 2, the 1 with the 1. So what this is doing is this is canceling out all of those non-distinguishable permutations for us. So what we're left with is at the top, 6 factorial over 2 factorial times 2 factorial times 1 factorial times 1 factorial from the bottom here, all right? Which is totally coincidental because we started off with, if you remember over here, we had 6 total letters. We had 2 G's, 2 O's, 1 L, and 1 E. So we came up with a general formula to help us out, and it turns out there was 180 different permutations of the word Google. Then we did one in class together. We talked about the word race car, right? So if we take a look here, there are a total of 7 letters, okay? And then I have 2 R's right there. I have 2 A's. I have 2 C's, and then I have 1 E, 1 factorial. So the formula would just be 7 factorial over 2 factorial times 2 factorial times 2 factorial, which gave us 630 different distinguishable permutations for the word race car. All right, there you go. Give me some feedback if you need to below.